Hello children, welcome back, and today we will be dealing with our next important topic. Before going to the topic, I would just like to recollect you one part from the previous class. Yeah, every time this recollection is going on because nothing in classical physics can go beyond Mr. Isaac Newton. So, regarding the term Newton, force, gravitation already are very much related. So, since we are studying about force, so of course this will come repetitively. Now, as I was telling, gravity, it works everywhere. So, since I am also sitting over here, gravity is working on me. So, any particular rigid body, I am again showing, since I don't have much examples, this. Now, this container, it's a particular cylinder type of container, as you can see. And so, when I talk about gravity acting on this particular cylinder, you should know that it acts on every possible particle, even on this. That is, this lid is one part, label one part, this sticker one part, this bottom a particular part, the whole body is of plastic. So, from this whole thing is made up of various atoms, molecules, might be a compound, so various molecules. So, in this case, whenever we see any point, if I point over here, anywhere, of course gravity is acting everywhere. There is no other option, that there will be no part that gravity won't be acting. In that case, if gravity won't have been acting over here, it would have been flying like this, but it is not. So, in this case, I would like to say, or ask you rather, when I give you to calculate the weight of this container, are you going to multiply the gravity with every single particle present here? I mean, is it possible or is it necessary at all? No. What is done is the weight of the container is given and you multiply, the mass of the container is given, you find out the weight by multiplying gravity. Now, where you got the result? Now tell me, mathematically you are very correct, or theoretically, where is it acting over here? Where is it acting over here? This is a cutout cardboard, as you can see, of a particular triangle shape. This again is the wheel from the previous class, of course. So, where all these are different types of bodies, right? This one. So, where is the gravity acting? Gravity is acting where all the forces are being balanced. Over here in this point, you can see that it is exactly the center of the disc. I can consider this as a disc because over here it is a circular part or circular object, and it is getting balanced particularly at this point. So, you can see that this is the center of the gravity. Nowhere else, if I try to keep it, try to keep it, if I can hold it, but I am using my two fingers, it is not getting fully balanced. I need the point where all the forces are getting balanced. So, this has to be this one. Okay. In the case of the triangle, I can always show you, since it is an equilateral triangle, so of course it will be getting balanced at the center. Now, please come to your book. I suppose everyone is having the 2021 edition of the book. So, please come to the page number 13. The center of gravity of a body is the point about which the algebraic sum of moments of weight. Algebraic sum of moments of weight. I suppose this term is clear to you by now. The plus, minus, clockwise, anti-clockwise moments and everything from the previous part. So, algebraic sum of moments of the weight of all the particles constituting the body is 0. The entire weight of the body can be considered to act at this point, howsoever the body is placed. I can place this disc in any different way. I will always see it to be balanced. Now, as there are various pictures in your book, I am going by them only. Circle or circular disc center, triangle, equilateral triangular lamina, then comes square particular device, might be like this, somewhat rectangle box. All these are having certain points which can be marked as their centers and at the center of gravity. Now, this is one of my guardian's bangle, a very used one. Just a hollow disc. Now, where is the center of gravity of this? Here, here, here. But every time the rest of the weight is acting other side. So, there can be situations or can be different shapes and structures where the center of gravity is actually outside its own shape. Here, in this case, it is the exact center. That means it is outside of the mass or inside this hollow part. So, let's talk about the note one by one. All the points of this note, there are 3 points in total, all will be important. First thing, the position depends on the shape. As I showed you, I still have certain various things. If this is an abstract type of cardboard, this is another one, no particular shape, this one equilateral, this one. So, wherever I want it, I will just require to know the shape of the body first. Whatever be the thickness or whatever be the weight, more weight, less weight, very thin, does not matter. Even if this cardboard would have been replaced by iron sheet, of course the weight would not have been same because iron is much heavier and dense actually. So, in this case, what would have happened? The same case as the equilateral triangle, that is, the CG would have been exactly at the center, even if this triangle is made up of iron sheet. So, even if this is a circular disc, if I would have cut out a circle of this cardboard, also the CG would have been exactly at the center and nowhere else. Metal sheet does not have a different CG of a circle than that of a cardboard sheet. So, Shape is the major thing, material is not important. I am not talking about center of the mass. I am talking about center of gravity. That is the reason it can be outside where the forces are acting, not the mass everywhere. Clear? The next point. It is not necessary the center of gravity always be within the material of the body. The best example, circular disc, hollow circular disc, especially hollow circular sheet, always outside the body. Outside the body does not mean outside the circumference area. Outside the body means outside these masses of the beads of the whole structure. Okay, am I clear in this case? Next, by the concept of the center of gravity, a body of weight W can be considered as a point particle of weight W at its center. Point particle, a very important concept starting from now till the entire of physics, whatever you study about. Point object is certain. For example, I am in this car, not I am literally, this is a demo. So, I am in this car or a passenger is in the car and the passenger is travelling from Kolkata till Assam or Guwahati particularly to say. In that case, whatever be the hundreds of kilometer distance, I just take the car from my home, I reach my place at Guwahati and I drop there. In between, I walk inside it or I sleep it inside sometimes. Does it really matter? No. That means the size of the car is totally ignored in the case when I talk about the distance. I only consider myself. The size of the vehicle in the case of this displacement is immaterial or irrelevant. My objective is to travel and to reach. I got from my doorway, it is at a certain point and fixed. My place in Guwahati, it is also a certain place, a particular hotel or some friend's house, that is also fixed. So, amongst this, maybe the car is 4 meter or 5 meter in length, ignorable. So, when we talk about the distance, we ignore the size of the vehicle. So, similarly, over here, when I need to calculate the mass, acceleration, point of application of the force, because see, it's just a simple cutout as I showed. W is acting everywhere. Here, wherever I have made the points, if I just make it closer over here, you will be able to see that there are some certain very small points also made over here, here. So, everywhere where there is a particle, there will be a W acting. But if I go on calculating like this, people will go mad. Then they have to calculate every atoms and molecule structure, which is not necessary. So, I take exactly the center of gravity and then I take it as granted as the whole body, then the weight acting on it and the calculation goes on. So, is the concepts of point, you can relate that it is exactly the point object, that means the CG point and no other point. I will not take the holes which I have made over here. So, I suppose it is clear by now, by maintaining the point object. The object totally is not shrinking to the point. I am just taking the center where the algebraic sum of moments is considered to be 0. The shapes chart is given. I don't think it is very much necessary to mug it up. In case you want and you are good at it, of course you are welcome. But see, there the diagrams are also given, and you can see these type of shapes available in your house, and I think you better go on with the diagram of the figure 1.37, and you can remember easily where the CG of the uniform shapes can be. Yes, uniform. Now, I was talking about the car. Where is the CG? Center. Here. Here. Inside. Where? Difficult. Now, when we talk about the center of gravity of an irregular lamina, like this. I mean, it's nowhere calculated to be shaped. This is a semicircular, this is looking like a quadrant or sector, and this is protruded. So, it is in no way to be calculated. So, physics does not like the word impossible. Let's make it possible with few devices, very small. In fact, I am showing it to you. If you want, if you are interested, I would literally like you to take the help of any guardian or any senior, and you can do it by yourself. See, an odd type of cardboard is hanging over here, shapeless literally. I just cut this triangle out of it, and this type of structure came out. Let's have a closer look. I have something to show you. There are some devices. See, over here what I did is I made 3 holes at 3 points of this lamina. One over here through which it is hanging, as you can see. 2 over here through which the thread is hanging. Number 3 over here through this another thread is hanging. So, all these are actually made and thread is attached at every point. 3 is enough. If you want 4 or 5 you can, but that will be very cumbersome. Why 3? Because to make a plane surface enclosed or to intersect, at least 3 lines are required. So, 3 is my minimum requirement. After that, if you want 6, 7, 8, 9, 16, as you wish. Now, the second thing is this. This is actually a conch shell, but I have done it to represent something. A plumb line. Now, plumb line is a thing where a solid mass, either preferably of stainless steel or iron, is actually having a hole at its CG, and it is hung with the help of a thread. Our physics lab has lots of plumb lines. For these type of experiments, we are sorry that it can't be accessible right now, you know the situation. So, I have just represented with a solid thing. I got this, so I just hung it up. The process. At first, after making the holes and the threads over here, what we are supposed to do is to hang the lamina. I just hung it from that nail placed, and on the top of it, I will just put this solid shell and leave both of them. Now, not leave means leave them permanently or so. When I tell them to leave, that means leave them, they will swing and then they will come at rest some point. Wherever they will come at rest, I am just going to take an impression of the line of this. I know no line has been drawn because this is not possible to draw. This is not a hard surface. You can see it's a curtain. Now, what after that? Change the side. That means hung this second side from the top, trace the line. Hung this third side from the top and then again trace the plumb line, what it comes to. Now, wherever all the three intersect exactly, that will be the point or the CG. Caution, a sharp pencil has to be used. See, the full experiment of determination of CG of an irregular lamina is given on page number 14 with a diagram of an irregular lamina. The arrow, the thick one, is representing the plumb line. You have to take the impression. Once the school reopens, okay, don't ask me when, but once the school reopens, of course, this demo can be easily shown. Not to worry. For the stable equilibrium of a body, its center of gravity must be as low as possible. It must be above the base and near the geometric center. Now, what happens is, when we talk about the center, it is not exactly coinciding with the center of gravity every time. We have to check it. So, every time, even if the center and the center of gravity exactly does not coincide, but it should be nearby. Not that the center is this hole and the center of gravity will be nearby. Not possible actually at any moment of time. Okay. Now, there are few other experiments like meter rule supported by a knife edge or the square sheet balanced on the tip of nail. See, these things are just like this one, right? You can just do and check many of the shapes and sizes cut out from different lamina every time, and you can hang it, or you can just put it on top of your finger and you can check it at home. It is not necessary that you have to be limited to this only. In fact, there is a question also in question number 10. All these you will be getting homework soon. Kindly follow the parents alarm every day and every time. So, there can be situations like that. For example, I am holding this lamina over here and I am there holding this over here. Is it the CG? Till what we have learned today? No, it is not the CG. But there is no place to hold where exactly the CG is. So, where will I hold it? I need to hold it somewhere. That is the reason I am holding it over here. So, this is the full concept of center of gravity. So, you can cut different, please don't cut any useful papers. Okay, waste cardboards are always available. You can cut different sizes, shapes, colors, of the same size also. What is my suggestion? You can cut of the same shape of different sizes, and also you can check whether the CG is at that point only or not. You can get different materials, like for example that of thin paper, that of cardboard, that of marble paper, that of chart paper. So, many things can be done using this. Of this, please over here regarding the charts, kindly follow as I said and continue. We will continue and meet in the next class. If you have any doubts, you can of course tell me. Okay, happy studying.